direct variation. So here we really need to read the words carefully because that's going to help us work on variation. It says the variable y is said to vary directly as x. So that's when we write it as y varies directly as x. Now we've got to change this to an equation for us to be able to work it out. So what we do is we say y equals kx, and then we need to find this constant of variation k. Variation involving powers. Now we'll get the same thing with powers. We actually need to read it carefully, and sometimes they might give us a graph, or we might need to work things out, but we do it exactly the same way. To find that variable, that constant of variation, that k, all we need is an x and a y value, just like we do in a straight line, and we can find k. Example 1, it says in each case use the table of values to determine the constant of variation k and hence complete the table. So it gives us the rule for part A, y is proportional to x squared. So if I was to work that out as an equation, I get y equals kx squared. And I know when x is 2, y is 12. So substituting 2 and 12 in will give me 12 equals 2 squared is 4. 4k, therefore k equals 3. And therefore my rule, if they ask me for my rule, is actually y equals 3x squared. Now you can do a check, and if they want us to fill all these in, we can fill that in there. So 4 squared is 16, 16 times 3, 48. And we can do vice versa, finding what the x value is here, which would be 8. So we can do all that. Part B says y is proportional to the square root of x. Now, square root of x is just x to the power of half, so that means it's y equals k x to the power of a half. And again, I can put any one in, whether it's the 1 or the 6 in. So I'll put sub x is 4 and y is 1 in, so I get 1 equals square root of 4, which is 2, times k. And therefore k equals a half. So therefore my rule actually equals y equals a half the square root of x, or x to the power of a half. You can leave it to it as you want. And when I work for x equals 2 out, I'm actually going to get 0.7. I'll do it to one decimal place. And for y is 1.414, I get x equals 8. Example 2. It says in an electrical wire, the resistance R ohms varies directly as the length L. So if I've got that, I've got R varies directly as L, and therefore my rule is R equals KL. But now I'll need to find what that K stands for to get my final rule, if they ask me. But part A says, if a 6 meter wire has a resistance of 5 ohms, well there you go there, that's going to help me find my R. So I'll just rub this off. 6 meter wire, that's my length, 5 ohms is the R, so 5 equals 6k, therefore k equals 5, 6. And my rule is R equals 5, 6 L. So the rest of part A says what is the resistance of a 4.5 meter wire. So the resistance will be 5, 6 times 4.5. And therefore, for 4.5, I get a resistance of 3.75. And you can write it in words. Part B, how long is a wire which has a resistance of 3.8? So if I write down my rule, 5, 6L, I've got a resistance of 3.8 equals 5, 6L times by 6. So when I times by 6 and then divide by 5, or rearranging this, so we get 3.8 times 6 divided by 5, that's my length, and my length ends up being 4.56 meters. I better write ohms on the other one. OHMS. I'm not writing them in words. You guys can finish them off in words. Example 3 says the volume of a sphere varies directly. So volume varies directly as the cube of its radius. So if I was to write that, I get volume varies directly. Cube of its radius is that, r cubed. And therefore writing it as an equation, get volume equals k r cubed. So we've done that part there. Then it says, by what percentage will the volume increase if the radius is part A doubled and part B increased by 20%? Well, we need to set an initial radius. So initially, we'll make radius equals 1. Okay, so therefore I get volume equals 1 cubed times k, which is just k. Then part A says if the radius is doubled. So if initially the radius is 1, now r equals 2. And therefore my volume will equal 2 cubed times k, which means my volume is 8k. It says by what percentage will it have increased? Well, it's gone from 1k to 8k, so the increase is 7k. Now percentage increase in the volume means it's 7k increase. It originally started with k, and to turn it into a percentage I times by 100. The k's of course will cancel, and therefore I have 700% increase when it's doubled. Part B, increased by 20%. Oh, originally it was 100%. When you increase it by another 20%, you get 120%, which means as a fraction it is 1.2. So now we get a volume of 1.2 cubed times the k, which actually equals 1.728 times k. So the increase will be 7.28, so percentage increase in the volume will equal 0.728 k divided by k times, of course, 100. The k's cancel again. I'll probably do that without showing all this step, and therefore I get 72.8% increase.